In this video, I'm going to show you some calculator tips on how to find zeros using a TI-84 graphing calculator. This will work on most TI graphing calculators. Before we actually try and find zeros, what we're going to have to do is talk about what zeros actually are. There's multiple ways that a problem can ask for the zeros. Zeros mean the same thing as finding the roots. Roots are x-intercepts on the graph. So that's where the graph crosses the x-axis. So if I draw a coordinate plane, here's my x, here's my y-axis. If I have a graph that looks like this, it clearly crosses the x-axis here and here. So this would have two zeros. Okay, so this has two zeros. If you notice, both of these zeros are on the x-axis, which means their y-coordinates are 0. So a problem could say, find x when y equals 0. That's the same thing as finding the zeros, or the same thing as finding the roots, the same thing as finding x-intercepts. If an equation is solved for y, it's said to be in function form. And if it's in function form, we can write it in function notation, which means instead of y, we can write f of x, which means the function when we plug in x. So when is the function equal to 0 is saying the same thing as when y equals 0, and that is the same thing as an x-intercept, which is the same as a 0 or a root. The one we haven't talked about here is solutions. Basically what that means is you're going to set the equation equal to 0 and then solve it. So that's why they call it solutions. So all of those things can mean the same thing. It all means finding zeros. So let's look at one example of a problem. This problem actually says, which of these has exactly two different zeros? So actually this problem doesn't ask you to find zeros. It asks you to find an equation that has two zeros. Okay, so if we look at these equations, we have four choices here, and we can eliminate some right off the bat. And here's how you can do that. You can look at the degree of each of these equations. A and B are both degree 1 polynomials. I know that because they have one variable and the exponent on their variable is an invisible 1 that we can't really see. That means that at most, these two degree 1 polynomials, also called linear equations, will have at most 1 0 or 1 x-intercept, because remember zeros are the same as x-intercepts. So we can instantly get rid of these two because we don't want one x-intercept, we want exactly two different x-intercepts, two different zeros. The second two, C and D, are both second degree polynomials or quadratics. Quadratics make a U shape like this, which is called a parabola. If we graph that on a coordinate plane, it could cause the graph to have two zeros. It could cause the graph to have no zeros if it looks something like this, meaning it never crosses the x-axis. Or it could cause the graph to have 1 0, which means it comes down and at its vertex it just touches the x-axis right here and then comes back up. So there's 1 0, there's no zeros, here is 2 zeros. So this means that at most these have 2 zeros. We got to find which one has 2 zeros. So one of them is going to look like this graph, and the other one's either going to look like this where there's 1 0, or it's going to look like this where there's none. So to do this, the easiest way is probably just graph these in the calculator. We don't actually have to find zeros here. We're going to graph them and look and see how many x-intercepts it has. So I'm going to graph the first one. If you go to y equals the top left button and you click it, let's put in letter C. I already have it typed in here, so go ahead and type that in. X squared minus 4x plus 4. And then you can either hit zoom fit or zoom standard. This will fit in the standard viewing window. If you hit zoom standard and it doesn't show it, you can always hit zoom fit and it'll show it somehow. But zoom standard is going to look best, so we're going to hit zoom 6. It's going to graph it, and it looks to me like there's just 1 0 right here, just touches right here and comes back up. So its 0 is at its vertex. So that means letter C has only 1 0, so that means the answer cannot be letter C. So it's more than likely letter D. It can't be anything else, but let's prove it. So let's go in here, we're going to type in letter D. Letter D is x squared plus 11x plus 24. And then we're going to go ahead and click zoom 6, or you can just click graph at this point because it's already on zoom standard. this clearly crosses the x-axis 2 times here and here. So that means letter D is definitely the answer. So the answer here is letter D, and we're done. Now, I said I would show you how to find zeros. This problem, they don't actually ask you to find the zeros. All they want you to do is pick the one that has exactly 2 zeros. So let's look at a problem where you would actually have to find the zeros. Here's one of those problems. I know there's a lot of writing here because these are all the calculator steps. Okay, but here's the problem. Let's look at it. It says what values of x are solutions. Now remember, if we go back a little bit here, solutions are the same thing as zeros. So really they're just asking for the zeros, or when the equation is equal to 0, or what is x when the equation is equal to 0. So let's go back to our problem. First thing we have to do is if we want to find zeros, which are the same thing as solutions, it has to be equal to 0. So what we need to do is subtract 20 from both sides to make this 0. So I subtract 20 here, which means in the equation, to keep it equal, I have to subtract 20 on this side. So I'm going to get this equation right here. And then I want to type that equation into my calculator. So grab a calculator. Let's go back to y1, or y equals. And we're going to clear this out, and let's type in this new equation. So 3x squared plus 11x and then minus 20. And then we're going to go to, let's just do zoom standard and see if it works again. So zoom 6. And it looks like it doesn't fit the whole graph, but that's okay because we only want the zeros. And we can see the zeros, again, because zeros are x-intercepts. Our solutions are here and here. We see them. Okay. Now, from here, there's multiple things you can do. So, if it's a multiple choice problem, you can do this problem like a substitution problem. And basically, you can plug in all of these values and see which ones output 0. To know how to do it that way, you can watch my other video on how to do substitution in the calculator. We're not going to do that way in this video, just to keep it shorter. So, the problem with that is if it's not multiple choice, it's going to be pretty hard to do it because that's just basically guess and check. So, I'm going to show you exactly how to find zeros in the calculator, and here's how you do that. So, we already graphed it, which you can do zoom fit or zoom standard. Zoom standard is actually going to look a little better here. And then we're going to go to second, trace, which is, we're going to hit second until you have that little arrow up here. Trace, so that accesses the calculate feature of the calculator. Obviously, we're going to want the second one, which says find the 0, so it says 0. I accidentally clicked the wrong one, so second calculate, and we're taking the second one. And it's going to say something on the screen that says left bound question mark. Here's what that means. You want to set a little window for the calculator to look, because if not, it has to look forever, because a graph really technically is continuous. It goes on forever. At least this graph does. So we have to set the window that it needs to check, and at the same time, it can only find 1 0. So we need to set the window just around this 0. So let's look at this one on the left. We want to set the window to basically check between here and here. So when it says left bound, we need to go set the left side to over here somewhere. So we need anything on this side of it. So I'm going to move my cursor by hitting the left directional key until I see like my little spider cursor. Oh, there it is. So now I'm clearly to the left of it, right here. So I'm going to say check right there. So I'm going to click enter. And then the calculator is going to say now set the right bound. So we want to be over here on the right side of it, which down here it's clearly going to be on the right side of it, even though it looks close. It's just to the right of it. So now that we're below it and to the right of it, we're going to click enter. And then the last thing it's going to say is take a guess where you think it's going to be. And it looks like these are just as far away. The guess one doesn't matter quite as much. You can usually just click enter and it'll work. And it tells you that 0. So that 0 is at -5, 0. If you look at your choices, the only one that's -5, 0 is letter D. So this is probably your answer. But let's go ahead and practice finding the other 0 and just to double check. So again, second, trace to get to the calculate screen. And then number 2 is 0. But now we got to set the left bound to the left of this other x-intercept. So I'm going to hit right until I get over here, until I see my little spider cursor. There it is. So here I'm definitely to the left of it. Maybe I'll go even further to the left of it just to make sure you guys can see it. It's right there. I click enter, there's my left bound, now my right bound, so see how I put an arrow here? So it's saying check between here and, now we need to set the right bound, so that's definitely to the right, so click enter. So this is literally saying check between these two arrows that it just made. So, whoops, wrong way. So there's the arrows that it just made. It's going to check in between there. Now it says take a guess. So get as close to that thing as you can, that 0. Looks like this is as close as I can get. Click enter. It tells you the other one is 1.3 repeating, which is 4/3 as a fraction. So our answer is definitely going to be answer choice D. At this point, you should either pause this video right here, that way you can read the steps to do this if you want to try some, or you can rewind the video to go back to see how to find zeros.